Hello guys, welcome back. So in this video we are going to see the graph traversal, because in the last video we have already seen graph representation using the uh, adjacency list and adjacency matrix, right? So we have seen already how to represent, how to build a graph, right? So to represent the graph, to build the graph, we have two way. Either we will use adjacency matrix or adjacency list that we have already seen in the last two videos. Okay, so in this video we are going to see graph traversal, right? And we'll discuss the traversals method. What are the traversal methods are there? So there is two traversal methods are there. The first is let's suppose DFS, and another is BFS, or you can say BFS and DFS. When we talk about the DFS and BFS, it's a quite different logics are there. How to implement that we will see. The algorithms are different, so let's understand one by one. Okay, so first we will talk about BFS. Okay, so BFS means breadth first search. So in the BFS, what we will do, first of all, why we are doing that, right? So we know that in the graph, right, there should be some nodes are there. Let's suppose like this is a node. Okay, like this, or this is a kind of tree, and tree can also be a graph, right? It is a graph. So you can say if this is a node, let's suppose I'll go with 0 1 2 3 4 and 5. Okay, these 5 nodes are there, 6 nodes are there, sorry. Then what we will do, we will how we will traverse that, right? So we'll see later how we are going to traverse. Means first we will go like this, then this, then this, right? Like level order we want to go, or we want to go by one, right? That we will see. So in the breadth first search, what we have to do, we have to start the source node and we will mark it visited. Means if once a node is searched, let's suppose this node is already searched, right? Then what we will do, we'll say we will mark this node and we'll say this is already visited, right? And what we will do, we'll put somewhere in the queue. Let's suppose we have a queue like this, right? Queue is like this, so we will put into the queue. So this node is already marked. Let's suppose I will put into the queue like this. Okay, so I have already traversed the root node, and then we will move to the next node like this we are talking about. Okay, so we will use this queue and we will keep track of the all the nodes that is already explored, or you can say traversed, right? Or you can say visited. Once this is done, then what we will do, we will start in queue that source node, and while the queue is not null, right, it is not empty, we will dequeue one by one from the front. Okay, and then we will process the node and will print it, or you can say record whatever we want to do, that we will do. And once all are visited, all the neighbors of the node are visited or marked, then we will say all are visited. Okay, means in this case, let's suppose we will first we'll put 0, then we'll put 1, then we'll put 5, then we'll put 2, then we'll put 3, then we'll put 4, right? So like that, this is traverse. Okay, so when all are traverse, what we will do, one by one we will check in the we'll take out from the queue, and then we'll process is this visited or not. If it is not visited, we will put into the queue, right? Like that we will do. Okay, so I hope you understand, but let's do some coding section so you can understand better, right? So like main what is the main characteristics here, right? So we will do like we will use the BFS and we will explore all the nodes level by level. Let's suppose in this case we are going with this, then we will go with this, right? Then we will go with this, right? Like that, level by level we will start traversing from the source to the all the nodes, right? You can say. So if you want to find the shortest path, right, so this is the best way to use the breadth first search, right? So so the shortest path, so BFS can find the shortest path in unweighted graph. If their weight is not given, that we will talk. If you already aware with the first video that we have talked about, right, where we have seen what are the weighted graph, what is the unweighted graph, right, like those things. Means weighted graph is having weight, right? If S is not having the weight, means it is unweighted graph, right? So in the case of unweighted graph, here we have not given any weight. So what we can say, in the BFS, if we do not have a weight, right, then we can go for the BFS to find the shortest path. I think you already have aware with that shortest path, right? We can find. So how you can find the shortest path, right? The BFS approach we can do, and you can implement that. We'll see a lot more about the shortest path algorithms that we will see in this video. And but for now, you think about BFS, right? We can use BFS and we'll find the shortest path in the unweighted graph. Okay, so if we'll talk about the complexity here, what are the complexity will come, right? See, if there is 6 vertices, right, we have to visit all the vertices, right, and then we have to put all in the queue. So we can say space complexity will come how, number of nodes, right? Let's suppose there is v is the vertices, how many vertices are there, so O of v, right? So this is your space complexity, O of v. When we talk about the complexity, so we have to do what, we have to check all the you can say vertices as well as this, right? So time complexity will take O plus v, O plus e, sorry, O plus e, not v plus e, you can say, right? O of v plus e, like that you can say O of v plus e, because there is e is a edge between these two nodes, there is are edges, right, like this. So we have to visit all the nodes are there, right? So we will see how to implement the code, right? So what I have told you, first of all, we'll take you can say a queue, and we'll put into the queue, and then we'll keep track of adding all those nodes which is already visited, that we will see. Okay, let's go to the program and we'll try to implement that. Let me go to the Eclipse. So what we will do here, we have created one function here that we can say BFS. It will take a graph and will start the you can say starting nodes, you can say from where we want to traverse. So you can take a root node also here. Okay, you can say root node. Now what we should do, we'll create a visited hash set, and we'll take a queue, right? So I will take a set, and the set contains, you can say, integer. I will take integer, and then we can say visited equal to new hash set, right? We'll take hash set like this. Okay, we can remove like this. So we have our hash set, so all the visited nodes we will put here, so we cannot revisit that, right? And we cannot go into the loop. Now for that I will take a queue, and in the queue, give me one second, this is a queue, and in the queue what we will add integers, right? All the nodes, right? And this is, we can say, queue, and this is nothing but your linked list, right? Linked list. Okay, like that. Okay, so you have created a visited node, and all the elements should be in the queue, right? That we have already seen. Now first of all, what we should do, we will add the front element that we are going to start from the starting node, that we will put into the queue. To put into the queue, what we should do, we'll add queue.add method, and we'll pass start. Now in the queue we have one first root, we have one root we have, and then we will mark it as a visited. So in the visited, there should be one element, right? So what is the element? The starting node. So starting node means root node is now visited. Now go with the another node from where we want to start. So I'm not saying here root, because see, in the graph we cannot say which one is a root node, right? So we can say starting vertices will start, or the end vertices will say, right? So start vertices, end vertices. Now coming back to the while loop, right? What we will do, we'll check in the queue if queue is not empty, is empty. If queue is not empty, in this case we will go to the queue, and will remove one element, right? That is called poll. We'll poll one element, and we'll say this is your current element, right? And this is nothing but your the node, right? So I'll give the name node current node, right? So from the current node, we will check its all neighbor, right? Or you can print here also. Let's go for the print. So we can see the current node, right? And this is nothing but our node. Okay. So here we can process the node, right? That means what we are going to do. We are processing the node, right? We are processing each node at a time. Now the first node we have, now we have already visited, we have marked it visited, and we have put into the queue, we have removed from the queue. Now we will process the queue, means we will check all the neighbors of this node. To check all the neighbors of the node, what we have to do, so we have a graph, we have, right? On the graph, if we will say get, right, and we will find this node, so we can get a list of what? We can get a list of its neighbor, right? Like this we can get. So we can pass here list of neighbors, right? So from the list of neighbor, if you will get here, let's suppose any value is there. Now from here we can make a loop. To make the loop, what we have to do, we'll go with one by one, right? And this is nothing but about your neigh bor, okay, bor, okay. We'll go with the neighbor and we'll take not the whole list, we'll take one by one element. I hope you understand, right? If you have any doubt, please ping me in the comment box. Okay, so you can see we can get the data. How we are going to get the data? Oh, sorry, we will not write equal, we have to write the colon, right? Remember? So like this, we have to traverse all the neighbors, right? All the neighbor node we will get one by one through the graph.get, because from the map, if we pass the key, we can get the values. So values are nothing but your neighbor nodes, means adjacency lists are there, right? So from the adjacency list, means neighbors, we can get one by one node here. Got it? Now what we should do, we'll check if, we will check if not visited. First of all, visited should not contains these nodes. Which nodes? The neighbor node. If the neighbor node is visited, then we will not process this one, right? If it is not visited, then we will mark it first visited. Okay, so first of all, we'll add onto the here, and then we'll say neighbors. Yeah, correct. Now we will add like neighbors, right? So all the neighbors, now we will you can say mark it as visited. Now what we should do, we should put onto the queue, right? So we have queue. On the queue, what we will do, we'll add here, right? So we'll add all the neighbors here. Okay, once your neighbors are added, right? Once your neighbor are added on the queue, now till the queue is not empty, we will poll one by one and we'll check its subsequent you can say nodes, right? In the case, let me say what I'm trying to say. Okay, so what I'm trying to say here, see, if let's suppose we have one node is here, right? And there is some more nodes are there. Let's suppose I'll go with like this. Okay, like this. Okay, let's suppose these are the nodes 1, 2, 3 and 4. Let's suppose first we have added onto the node on the queue is 1 here, right? One queue we have processed, means we have got from the you can say queue, means we have removed from the queue. This is done, means once this is done, we will add its two children, right? So in the map, how we can get the data? So on the map it is like this, what is the neighbors 2 and 4, right? And another, if we'll talk about for the 2, we have what, 1 and 3. If we'll pass 3, we can get 2 and 4. If we'll go for 4, we will have 1 and 3, right? So this is your map, right, where key is here and values are here, right? That we were talking about here, right? So this is your key and this is your value, right? So what we are doing here, we will add onto the queue. So one is done, right? Now what we will do, we will get all the neighbors. What are the neighbors are there? So one, you can get from the neighbors from here, you can get two things, right? First we will get 2 and 4. You can see the map, right? You will get 2 and 4. So we can add 2 and 4 here like this. Okay, once 2 and 4 are here, right, one by one we will go like that. So we'll get the neighbor here. If neighbor is not in the queue, we will put on the queue. That we have done, we have put onto the queue, and then sorry, we will mark in the visited, and then we will put on the queue. Then we have done. We will again come back here in the, because queue is not empty, we'll poll this one. So we'll poll this one, we'll go with its all children 1 and 3. So we'll add, 1 is already visited, so we will not put in the onto the you can say queue. We will add only 3, right? Like that we will process. You understand? Because see, 1 is already processed, but when we pass through the on the, we will map, we will get the map gap, we will do graph.get, right? From the map.get key to, we'll get what, 1 and 3, but 1 is already processed here, so we'll add only 3 here, right? So like that we have to process one by one, and then we have to check. Okay, I hope you understand. Let's come back to the code. So like that we have created all the function here, and then we can test the function, right? So we have already created a main method here. How we are going to test? Let's see. We have already created the method graph here, so I'll keep the graph here. Okay, so to create the graph, what we have to do, we have to do new, and then we'll pass has map. What we'll do, has map will do. Okay, so your has map is ready. Now we will add onto the graph. So onto the graph dot put we will do. So once graph dot put you will do, what you can find here, give me 1 second. Okay, so you can find, we can put all the elements, right? Let's suppose I will add 1, and here we'll add a list of elements, right? So we can write like arrays dot list is as list here. We can use arrays dot list, and we can pass 1 contains what 2 4 and 1 and 4, right? Like that. Or you can write a random number also like this. Okay, I'll go with this 2 and 3. Similarly we'll add all other elements. I will update in 1 second. Okay, so 1 is there, then we are going to add 2, let's suppose. So 2 contains not 2, but it can contain what, 1. Let's suppose we'll take 1 4, or one more element we can take, right, 5. And similarly if we'll go with 1 3, right? Let's suppose 3 is there, right? So then what we will do, we'll add 1 and 6. This 1 and 6 we can add. Similarly if we will go with the 4, we can check for the 4, we will add only 2, let's suppose, like that. And then we have 5. So 5 is connected with only 2, and we are done. Let's suppose one more we will add for the 2, that is nothing but you can take a 6, right? Or you can add, you can change here, no problem. We can take 3, right, like this. So your graph is ready. Now what we have to do, we have to do BFS. To do BFS, we can make it static, so that we don't need to call the object, right? We can write BFS, I mean we can call the graph here, graph. Our starting index is nothing but 1, we can take, right? Starting node, starting vertices. We can run, right click, so you can see here what we are processing. First we have process node 1, then node 2, then node 3, then 4 5 and 6, like that. Okay, so I hope you understand this video. If you really like this video, please hit subscribe this channel. And for the graphical representation, let me tell you how to implement what we have done here actually. See, yeah, so what we have done here, let's understand what we have done here. So we have graphed this one, right? So we have 1 here, then in the 1 we are going with 2, then 2 is going to 3 also, 1 is going to 3 also, right? Once we are going to 2, we are getting what, 3, So we can say 3 is done. Now 2 will go to 4. We will traverse 4. Now what we are going, 2 is connected with 5 also, right? So we can take 5. You can check here also, right? You can check here, right? Like this. Then what we have here, when this is done, now we are getting 6. So after the 6, there is only one 6, we can tell like this, right? So in the BFS, how we are traversing here, we are taking here, you can say from the node 1, right? Because we are doing from what? 1. Starting vertex is 1, right? Here. And if we are going with the vertices 1, in that case, how we have to traverse? We have to traverse first 1, then 2, then 3, then 4, and then 5, and then 6. Like this we have to go. Okay. So I hope you understand this video. In the next part, we will see the depth first search, and we'll do explanation there. Thank you. Thank you for watching this video.
Thank you guys. Thank you for watching this video. And if you really like this video, please subscribe this channel and